or visual difficulties or problems, please indicate, react, and allow us discuss it in the chat box to let us know, and we'll address it right away. Just a brief introduction about Midas as a company. Midasoft is a subsidiary of Midas IT, which is a South Korean company. We develop a total solution services for not only bridge, but building, geotechnical, as well as mechanical engineering. Our software solution is trusted by thousands of companies around the world, and we strive to provide the best product and services. We are currently located in 19 countries across the US, across the world, apologize. And we currently have a user base of over 300,000 licenses and users across the globe. I'd like to take a moment to briefly introduce Yoon Lin, our presenter for today. He is an experienced and specialized in load rating engineer. He's currently working at Gresham Smith, and he has experience within the DOT as well in Virginia. His expertise and experience has led him to be a manager in multiple fields, and he is working on creating efficient processes for bridge evaluation tasks, as well as earning him the Distinct and District Engineers Award. His presentation today will be focusing on creating efficient workflows, and he has experience utilizing programming languages like Python to optimize his team's productivity and automating tasks. So without further ado, I'm going to bring this presentation and the speaker over to Yoon so he could begin his presentation. Yoon, would you be able to uh, present your screen now?
Yeah, I'm waiting for that button to show. Not yet.
Okay.
There we go. Just give me 1 sec. All right.
Perfect. Take
Can
it
you
away,
all?
Yoon.
All right. All right. Thank you very much. Thank you for the introduction. Well, my name is Young Lin. I am, by definition, a bridge load rater. So the difference between a load rater and a bridge design engineer is that we focus a lot more in terms of bridge analyses, and therefore we focus on efficiency of the modeling a lot more. And that leads us to think about being creative and innovative in terms of developing tools for ourselves to be able to model bridges more efficiently. All right. Um, I'm going to be focusing on developing a API application today. So we'll see how a user-defined API can be integrated into your modeling process and really be efficient and enhance your modeling experience. So as a problem statement, I'd like to start out with the very basics, pros and cons in FEA modeling in general. So we are here standing in front of Midas Civil because we like its accuracies. A lot of times the accuracy can help us avoid unnecessary postings, so we like that. And we also like its versatility and visualizations. We're able to model more complex structures, and its visualization really helps us to understand the model and the results. It helps us to verify the results visually, which is a huge plus. Now, on the downside, inevitably, we're going to have to go through a steeper learning curve to learn how finite element analysis is done differently from the traditional line grid analysis. And creating a model is going to be more labor intensive, sometimes way more labor intensive. The results can only be as good as the input. So today, hopefully, I can convince you that if you develop something for yourself, you can alleviate labor intensivity issues. At the same time, because we're automating a lot more things, human errors can be reduced and controlled. The Midas Civil offers a wide range of capacities and flexibilities. Using these four control bars, you can pretty much create anything you want. Now, inevitably, that brings us a steeper learning curve, especially for the users. So a lot of times the new user will just turn straight forward to this structural wizard tab. And what my message is that the structural wizards are great, but they're not a perfect cheat code to avoid learning curves. It can be beneficial if we want to create quick models and perform some parametric studies, no doubt about that. But we have to realize that the wizard have their own learning curves. It sometimes hinder your growth as a finite element modeler. And lastly, it is not tailored for your individual needs. Let me elaborate the last point a little bit more. So for me, for better efficiency, 95% of my bridges is going to be done in a line girder model. So I will not choose Midas Civil because the speed. But I am only here because I have a bridge that is geometrically irregular. And we also have to notice that these structural wizards are designed for standard and routine structures. So it becomes hard for me to find a use case to use these wizards. An alternative solution is to design something yourself, right? So if we're able to develop our own applications, we're able to customize the flexibilities to include the flexibilities that we actually need. For the flexibility that we don't need, we're going to automate them all. And it also allows me to include additional functionalities that's not originally within Midas Civil. I can also make quick adjustments throughout the project cycles. And lastly, creating a application yourself, it really forces you to learn the basics a lot better. And at the same time, it allows you to repeat the basics in a programmable way. So it's really good for your growth. So let me just take a quick moment to play this video. In this video, I will be creating a 7-span structures with, with some geometric irregularities. I will also complete the preliminary beam design with the API functions. So on the right-hand side, it's the program that I created. On the left-hand side, that's Midas. So we're creating a 7-span structures with 8 beams, typical beam spacing of 8, and the skew angle of 15. So everything is done. We're going to push everything to Midas Civil directly with one click. So as you can see, material properties sections are being created as also with the nodes and elements. All right. We're going to turn the synchronization on. So from now on, everything that I do on the right-hand side is immediately completed on the left-hand side also. All right. We can toggle the beam continuity with one button click. And we're going to customize span 2 to be 125 foot instead of the default 80 foot. For some additional flexibility, we're going to turn some bents to be not completely parallel to each other. Bent 5, bent 6, and also bent 7 will have a different skew. All right, now let's put some flares into these beams. For bent number 0, spacing 0, I'm going to make it 14 foot. So you can see the exterior beam flares up, and the same thing will be completed for the lower beams. All right. So for the end bend, I'm going to change the spacing to a uniform 11 foot, so it has a uniform flare. We're going to do some beam designs, just picking one of the most typical 80-foot spans, assigning it to 5,000 PSI concrete, and we're going to use the Ashto Type 3 for that beam. So you see it's completed. To save us time, we can copy this beam design to the rest of the beams because I know a lot of the situations fall into this category. All right. So I know that in span 2 it's not going to work. I'm going to change the concrete to 8,000 PSI as well as the beam shade to bulb T63. Okay, I'm going to change some design settings to make those sections show different colors. Okay. Copying that beam we just designed to the same span. So span 2 can have all bulb T63 with 8,000 PSI concrete. All right. We're going to perform some preliminary checks. You can see that dots is falling underneath that design curve. So we're good there. We're going to check the same thing on some of the weird spans. So beam length varies. So you see there's a deficiency there. And for the end span, it's a little bit short. So we're going to change those designs to some beefier beam shapes. So for span number 4, we're going to do, what did we do? We're going to do, let me see. We did a type 4, ASTO type 4 beams. I believe I've chose the different beam shape for the last span. So that's bulb T54. Okay, so that's not now all completed. We're going to recheck the designs for the current spans. Okay, much better, much better. So now we're going to focus on beam 1 in span number 2. All right. So the API gives me the flexibilities to move the nodes to the location that I wanted them to be. So in this case, I wanted to create a node at shear critical locations. So I could drag that node over, and by specifying the element length, I can pinpoint that node locations as soon as I click OK. You see the same thing is done in Midas Civil side. You're going to move the end node 95% of the span, and it's completed. So this view also allows us to give different sections to each meshed elements. Not that we need it for pre-stressed concrete, just kind of show the capabilities there. We can also modify the whole beam. And I'm going to put the beam back to its original shape. All right, so the bridge framing is pretty much completed there. So first, let's get rid of the definitions first. An API in layman's term, it is something that you create and to bring in a few different softwares and let them talk to each other. And a REST API allows you to send command over HTTP to the server, okay? And there is 4 standard methods within the REST API, which is get, post, put, and delete. You can get informations, you can post new informations, you can update existing informations, and you can delete informations. Now, what I want to stress about this is that the REST API request is stateless and independent. What does that mean? Servers will not save any of the previous requests you send to it. Therefore, each of the REST API has to be independent, and it has to contain all necessary informations for you to complete those requests. Okay. All right. So on the right-hand side of your screen, it shows you the folder structure of my program. So on the root folder, I have a main program, which is responsible for the graphical user interface. I've also injected personalized functions and tools for me to use. The mappy class, which is imported into the main function, is responsible to connect with the server and send API requests. It also includes some basic functionalities for modeling, such as creating a section, creating a node, which can be used in the main class. There is a few section classes to handle different beam types, such as pre-stressed concrete, reinforced, and steel I-beams. So this is the flow chart. This program first takes its user input, process them. The user input is going to be generic, basically how many spans, span length, beam spacing, and so forth. It's going to take those generic informations, massage them, and then create something called a bridge matrix. This variable is in JSON format. it is directly control 4 different JSONs for materials, sections, nodes, and elements. Okay. And then once any changes is made, it's going to use the REST API functionality that's developed by the Midas Civil through the server and directly to your control panel. So realize that you can be doing this in a distance. It doesn't have to be your computer. You can be controlling somebody else's computer using this API functionalities too. So we're going to focus on this beam matrix today. I'm going to use this as an icon or indicator to show the progress. Firstly, creating a material. That's the most fundamental task we're going to have to do, modeling a bridge. So on the left-hand side, it shows you how it's done in Midas Civil. There are 3 main inputs. The material type is concrete, the standard, as well as the strength. On the right-hand side, there is a user-defined function. Actually, this should be called a method. When a function is sitting underneath a class, it is now called a method. This method takes those 3 input and then create this mat JSON, which is mentioned in this matrix right here, update it, and then it will be later used in the API request to change things in your Midas control box. Very similar. This is how you create a section. So in this example, we're going to be creating an ASTO type 3 beams. You can see the inputs right here, and the same input is being used in this method. Now, these if statement is going to try to match this user input with these pre-existing beam types, actually beam shapes. So in this case, let's say ASTO type 3. And then these dimensions on the left-hand side are being pre-stored in these lists, so it can be directly used. For joints on and off, user-defined symmetries, as well as the user-defined offset, they can also be controlled here. Basically, anything that shows up on your screen, if you want that flexibility, you can bring that in. All right, now we move on to creating nodes and elements. This is going to be a little bit more complex. So what I do is divide and conquer. So we're going to first look at how you can create a single node. So this method under the mappy class create a single node using the information of the previous node. All right. So to get the input, x, y, and z is the coordinates for the previous node. T is the angle, and L segment is this element length. Okay, so using a basic equations, you can return the nodal information for the next node. Okay, so remember this function, create next node on a straight line. In this next method, that method we just talked about gets used here within a loop. So what this method does is that it creates all the nodal locations within a single beam. It could be any beam. The information collected will then be used to update the node JSON for API request. As I mentioned, the beam matrix that controls everything always gets updated anytime I make a change or create something. For element creation, we simply connect the consecutive nodes to make those elements. Those are relatively easy. However, we're going to have to deal with every element's material ID and section IDs. It gets a little bit complex when the beam is non-prismatic, but in this case, for pre-stressed concrete beams, we don't have to worry about that. Remember the previous 2 methods we just did, creating nodes and elements for a single beam. Now they gets used in another layer of loops. Now this is the 3rd layer. The purpose of that is to create all of the beams within the bridge. For instance, if we have a 3-span bridge and each span has 5 beams, we're going to be running those methods 15 times. My goal is not only to automate a bridge model, but also remain in control for me to make changes to refine the bridge geometries. Or if the roadway people wants me to change it, I can easily change it. So I'm doing that through the accurate numbering of nodes and elements. So let me show you. We're going to take a random example. Here's a 5-span structures. There is a zoomed in picture in Midas Civil for span number 5. If I simply select a random node, this nodal ID is 50203. It's span number 5, the second beam, and node number 03. Similarly, element number are named the same way. In this case, I just simply took the beginning node to name this element. To name a beam, on the green box, I simply used S5B8. That stands for span 5, beam 8. So at any given time, if I wanted to change any beams, every node be included, every elements being included can be directly in control. I'm going to skip the slides, but feel free to refer back to this slide later on when you're creating your own API applications. I think it's going to be beneficial. This is basically the way I'm storing the modeling informations, just letting you take a peek of what's inside of this B matrix. All right, so after that mappy class, finally we get to this main class. I'm not able to explain every single details of this because it gets too long. But what I can say is that this is where you will leverage your engineering experiences, programming skills, and everything that you have to create something for yourself and your team. I'm going to quickly go through the program that I created. I have a menu bar that can save and load models. It can perform REST API requests. When the synchronization button is on, you are basically doing two things at the same time. This first control bar allows the user to set a basic geometry or framing plan for the bridge. This drawing canvas shows the current bridge framing plan. It shows you the selection of the span, the beam, and the bend. The button on the lower left allows you to toggle the beam continuities. On the right, it is simply zoom control. The second toolbox allows you to refine the bridge geometries, setting individual span length, beam spacings, flares, or different skews for each bend to satisfy my regular needs for bridge modeling. This control bar allows you to design a beam, and the design beam profile is shown here. Okay, and it does give you a visual in terms of what materials on it and what sections on it, how many elements, and you can drag those nodes to make it a different location. User can set the number of elements for any beam on the lower left and copy the current design to any other beam or to any other group of beams. That's just going to be a time saver there. All right, next. So we just looked at an example where we can create a framing plan with regular beams, but complex geometries. Now this time we're going to shift the complexity back to the beam shape. Now we have a haunched reinforced concrete T-beams there. Now we all know we're going to have to do some taper shape in Midas, which is going to take you some time. So this example shows you how we can automate some of the tasks. A brief overview of this bridge: 3-span, 48, 63, 48. The length of the parabola is 16 foot. It is 25% of the middle span and 33% of the end spans. The beam depth varies between 30 inches to 51 inches. Okay. So this time I'm just going to go straight posting the default 3 spans. We're going to change span 1 to 48 foot. Once that's done, I can push an API request to Midas Civil to change those nodal locations. Okay, and we're going to turn the synchronization on from this point, changing span number 3 to also 48 foot. Span number 2, 63 foot. All right, we're going to design some beams. We're going to start with the middle span, symmetrical haunch. So first, it allows us to define the min sections, meaning the shallowest beam section, which is 30 inches, 8-inch deck, and 18-inch bottom stem. For the max, everything else is the same. The beam depth becomes 51 inches. All right, we're going to call this a symmetrical haunch, parabolic variations, and we're going to set the length of the parabola using percentages. So 25 and 25. The middle portion is calculated automatically. So as soon as we push confirm, you can see that haunched beam shape is being created in Midas Civil. I'm going to scroll down to the automated tapered sections. As I'm clicking through, you can see where those sections is being used on your model view. All right, we're going to do the end spans. Actually, I forgot about the material. We're going to do the 3 KSI concrete and then copy this thing to the rest of the span, rest of the beams within the same span. Okay, end spans. Everything is the same. The program remembers your previous sections, so we're good there. We're going to call this a increased haunch, increasing haunch, and parabolar shape, 33% haunched area. It's working the Midas and then create that beam. Okay, copying that beam to the rest of the beam in the span. Now it gives me a reminder for that yellow color because I forgot about the material. All right, so I'm going to check where 3000 psi concrete is being used in Midas real quick to make sure everything is accurate. As you see, first 2 spans are all in that material. All right, so the last span, this time same dimensions, but we're going to use a decreasing depth. Parabola, 33%, so we're good to go there. Putting a material and copy that beam. Okay. I can close the gap by toggling the continuity button. So now it's 3-span continuous. Now here's the question. What if span number 3 has a flare? Realizing that the tapered shape has 2 different dimensions needs to be tapered. So I'm going to first change the geometry to a flared shape for the end span. And now you can see that the top flange width no longer satisfies the tributary width. So we're going to design that one more time with the same steps. So this time I'm opening up this window. You can see that the B dimension shows it varies. The program realized that the spacing is varying, and we really don't need to do anything there because the computer already have all the informations. We're just going to say decreasing depth, parabolar shape, and simply click confirm. If I copy that beam design to the rest of the beams in that span, you will see that the space gets filled up. But again, I forgot about the material, so it's showing me that. I'm going to put that in real quick, and we'll be done with this model. All right. So let me quickly recap what we have done today. The personalized or user defined API applications is going to allow you to customize your own modeling procedures to include only the flexibility that you desire. Okay. If you don't need the flexibility, you will have the choice of automating them all. Okay. And certainly it's going to be an efficiency booster. It allows you to remain in control of the modeling to make real time updates without having to redo the model. And lastly, it's going to be user friendly. Why is that? Because you designed this thing, you can basically make it you friendly, as user friendly as possible. Now, I really wanted to stress this point. Throughout the development of the application, you're going to be constantly battling these two things. One side, it's the simplification, and the other side is the control flexibilities. If we want to include simplifications, if we increase simplifications consciously or sometimes unconsciously, we are losing control flexibilities. So, what I recommend all of us do is that before we start developing this program, we're going to have to well define our objectives and have a distinctive list of the flexibility you would like you and your team to have. And use that as a reminder throughout the development that you do not want to oversimplify things and be losing those crucial control flexibilities. All right, so before I close, here are some of the future tasks I can think of. Of course, I can put a complex bridge alignments, putting this bridge on a curve. I can include more bridge types. I can add features to include other bridge components. Um, I can add features to apply common load definitions, load cases, and load combinations. And last thing I would do is networking with other professionals and developers, basically grow as a community and learn from each other. Now, I want to mention this webinar as well. It was in 2019. So this is another method you could automate your bridge models, but this time without the assistance of API. So if you don't have the NX version, a lot of the similar things can be done, but in a different way. So just to be very brief, that the way it's done is that basically it's reverse engineering the modeling process. We start out by understanding the script file and then write computer code to automate the script file. That's the way we're automating the models. And the script file can be directly loaded by Midas Civil. So what is lacking in comparison to API is now sometimes to make changes, it's going to be a little rough. So it's good for creating models similar to the structural wizards, but to make changes, it's not as good as API applications. Okay, so this is my contact information, email, websites. If you need bridge load rating service or second opinion, or if you have a bridge that's hard to post, you want a better solution, a better load rating, please let me know. And Beta, let me hand this back to you.
Thank you, Yoon. There's quite a bit of questions. I've been trying to organize them so that way we can address them easily. So what I'll do is I'll share my screen again, so that way you could take a look at the questions one by one. Um, we still
Okay.
have some time left, so we'll try to address as many as we can. Give me 1 second. Okay. All right, Yoon. These are some of the I'll keep posting up the questions as I see them, just so you could
Okay.
kind of take a look at them. And I think a lot of obviously, most of the questions are directed towards you. So I think you could kind of start there, and I'll move on to the next slide as you finish up the last question on each.
Sure. I'm going to start from question number one. Did you use a particular Python open source library for the GUI or build it from scratch? Well, there is plenty of options for open source of GUI libraries. There's a few comes into mind. The first one, or the most commonly used, is called tkinter. Um, there is PySimple GUI. What I used is a more enhanced version of tkinter. It's called custom tkinter. That gives you a better view, basically enhanced capabilities as well as the graphics. And yes, for the second question, basically this person was asking if we can automate reporting through API. It's definitely in there. So what I would encourage you to do is if you can find it, send me an email. I'll forward that link. There is a comprehensive manual for you to get started with Midas API. So I'm going to put it in this way. So if you can do it in Midas Civil, I'm 99% sure you can do it within the API. You don't have to do it all in an API. You can basically have two things laid out to you, side by side, and you can do things on both ways. So that's definitely doable. So question number three is similar to one, so I'm going to skip that. That's correct. So this person is asking about the synchronization, how it's working. Um, Without the synchronization, what we're simply going to do is that once we make a change, the B matrix gets updated, and all the JSON files associated with it gets updated. When we turn the synchronization on, we're going to have to design a sequence of sending the request to the server. So, for instance, if I want to add a few nodes to a beam, what am I going to have to do is first update the beam matrix for that purpose and then send that information through. There's two things I want to do in order for me to do that. The first one is I would like to change the unit. In my case, it's feet. When we were talking about nodal locations, we typically use feet. So we're going to have to adjust the unit before you send the actual request there, or you could be finding your model completely out of scale. So, and some of the more complex requests could be a bunch of them just be in a sequence. As for example, I just designed a beam. I want to push that in. It could be multiple commands being sent over to the server, such as putting all the meshed elements to this material and then putting all of them in this section. So they have to be carefully designed in the correct sequence and then executed on the right button as you intended for. And beta, I'm done with this page. Oh, there's really a lot of questions. Great. Well, for the first question, I think the better source to ask is Lucy. She has, or actually, I'm sorry, Beta's here. So ask Beta. He has a large developer teams that can sometimes accommodate your request there. All right. Second question: what programming language? I think all of them works. If you're good at Excels and VBAs, do that. If some people use Rhino, some people use MathCAD, even some people use C language or Python. Basically, you name it. There is a way for any language to work. If you refer to the manual, which actually, Beta, I can send that link to you if you can forward it to everybody. You can see everything as a possibility.
Of
The
course.
API option is not available in the plain civil version. So, in order for you to automate things there, it's only available for the NX version. Um, in order for you to automate things there, you can slightly change the program. Instead of doing it through API, you can do it through the command. What's it called? I think it was called something like command input. You can put your
MCD
code there.
command shell.
MCT command shell. There you go. So you can do similar things in that route, or you can use the end slide that I provided, basically automating the whole model by artificially creating a script file outside. And for question number 4, can you make your own plugins? Absolutely. Actually, the product is already launched. There are two things you can do. You can do the things I've done, is basically separated from Midas Civil, but involved in your modeling experience. That's way number one. Number two is that you can even design your button inside of Midas Civil NX. So if there is something you use every single day, you can do that. You can include additional buttons to do the things you would like to do. Number 5 is a really great question. So one of the purpose that we want to do an API is to bring in a few programs and let them work together. So just think of my Python code as a glue. I'm basically trying to connect every single tool that I can get my hands on, or I can develop my own tools and let all of those to be working with Midas Civil. So that answer is yes. Basically anything you can think of, it is possible. Good for this page? I think question number 1 we already touched. To put it in a simplest form, basically anything you can do in Midas Civil, you can do it using the API. Everything is possible. The first version, how long does it take? Um, it's a tricky question. So depends on your level of your skills. Mine is not very good, but depends on how fluent is your programming skills. You can develop them faster or slower. But what I'm going to encourage you to do is that make a very simple program. It could be defining a single material to Midas Civil, create a single section, create a single node, create a single element. Now, what I'm going to say is that as soon as you see one command being pushed in Midas Civil, that's really going to be a huge confidence booster. After you see that happening, you realize that the only thing that's going to limit you is your imagination. So go from there. Just do something very simple, and we can build complex stuff on top of it. So number 3, same answer I provided before. Different programs can be brought into this. If you would like to keep informations of the model, I think it's a really good idea, by the way. It can be done. It's actually can be easily done. Batch processing, that one I am actually not sure. Um, the way I can think of is to queue them up and do it one by one. Batch processing in parallel, I don't know. Maybe Beta can answer that question better. Number
Sorry,
5,
yes. In terms of this, I'll answer this portion. It is possible depending on what kind of format that they put it in. For the person who asked this question, we'll provide some additional documentation. And for some of the questions that you can't answer because it's more logistical in terms of our software, we'll provide some more information documentation for these.
yeah, yeah. I think this guy's question is really good. I can think of that application being used for parametric study. So from my experience, or in my opinion, parametric study could be the single most powerful tool for us to gain experience in the modern age because of the computer technologies. If we can perform parametric study on the bridge components, you really going to gain a lot of the knowledges that weren't possible in the past because you can see results relatively fast, put them in a plot, and then you start understanding how each input is influencing your output, in what way it's influencing it, how sensitive they are, I really encourage people to do that through API. It can help you to create multiple models in a short period of time. It's definitely a fantastic tool. Um, yeah, if you have additional question for batch processing, I think Midas's team can better answer that. Number five, we've answered that one too. API is just a glue for different things to act as a group to help each other, basically.
We'll
I'm good
take
on this
one more
page.
question. Yeah,
Okay.
we'll take one more question because I've made three more pages from the questions. So for the sake of some of the time, the last question that I'll read out to you, I'll just read it out because it just came in. If you already added beam loads to a beam element using post, what happens if you need to add more beam loads? Should I use put instead of post, or do I need to redo the whole JSON?
Oh, great question. Remember, there's one of the slides I threw out the definition of REST API. It means that each request has to be independent, stateless, and independent. It has to contain all information that's needed to do this request. Now, that also suggests that the current request you're trying to push in does not see what's been done in the past. Okay. So for you to add additional load, you can simply use the post command. For you to change the existing load, you're going to have to use the put command. Now, the tricky part is how you're going to locate the load you're mentioning. So for me, I haven't got there yet with loads, but I know it can be done. For me to change information of my nodes and elements, I simply use B matrix to include the existing condition, existing informations, and call them as I need to. I hope that answers the question.
You and I appreciate it. I think there are more, but what we'll do is we'll compile everything relative to the questions that you can answer, and we'll share them with you. And for those who ask, we'll respond back to you guys with the responses from Yoon regarding some of the questions you had regarding his API module. Um, at this point, we're going to conclude, but we want to add that the next session that we're going to have is a part two to Yoon's session today. He showed the video of how his tool works, but he'll be able to go more in detail in terms of actual application, in terms of actually doing a brief model of it the next time. We'll let Yoon decide in terms of what kind of structure he's going to be doing um, to his discretion. But I believe to those members who participated today, it would be a great session to follow up on to actually see more. And I believe the questions will be very different from today to next time, Yoon, because they'll actually see the application and ask more how-tos as well as some modifications to the model that you're creating.
Yeah, yeah. Hopefully, I'll be adding some of the future tasks into my existing program. And I'm going to think of what's the best way. If you want to email me your questions, maybe I can better cover that in the next section.
Excellent. Well, I think that would be, I think that concludes everything for today's session. I would like to thank Yoon for his presentation today and taking time to actually present everything and just his information. It was very helpful, and I'm sure everyone here also appreciates it. I'd also like to thank the rest of the members and attendees today for participating and joining the session. So we'd like to thank you again, and we hope you have a great day. And please, one last information is for those who are asking about the presentation slides or the recording, this will be provided via email to everyone as a recording with the link, so that way you have access to it. But thank you again. Have a great rest of the day. Have a great evening. Thank you.
Thank you, everyone.